This is a scale model of human spaceflight, with the Earth shrunk down to the exact relative size of a standard basketball. If you map the International Space Station on this scale, it hovers just half an inch off the surface. That tiny margin is low Earth orbit. And since December 1972, every human being who has left this planet has stayed strictly within that half-inch zone. On April 1, 2026, 4 astronauts finally broke out of that holding pattern. They strapped themselves into a capsule and fired nearly 9 million pounds of thrust into the night sky, aiming for a target 400,000 kilometers away. This rocket, the Space Launch System, stands 322 feet tall. It generates 15% more thrust at liftoff than the Apollo-era Saturn V, making it the most powerful vehicle ever built for a crewed mission. But escaping Earth's gravity after a 50-year pause required more than raw physics. Building a machine with this much power involved a series of compromises that made it an economic dinosaur before it even left the launch pad. Modern commercial rockets return their boosters to the pad for reuse. The SLS does not. It costs approximately $2.2 billion every single time it flies, because minutes after liftoff, $2 billion worth of precision hardware plunges into the ocean and is never seen again. The reason for that staggering price tag traces back to 2010. When the government attempted to pivot NASA toward commercial spaceflight, lawmakers from states heavily invested in legacy aerospace manufacturing revolted. They passed a law legally forcing NASA to build this new rocket using 30-year-old refurbished space shuttle components. Inside Washington, D.C., it earned the nickname the Senate Launch System. Yet, this politically compromised vehicle was exactly what Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen trusted with their lives. The uncomfortable reality of space policy is that perfect efficiency rarely survives a budget committee. The exact political dysfunction that made the SLS astronomically expensive is also what kept the funding alive across 3 different presidential administrations. Once free of Earth's orbit, the Orion Capsule integrity crossed out of our planet's protective magnetic field. As the Earth receded, the crew entered an environment of extreme cosmic and galactic radiation that no human had experienced in over 50 years. By Flight Day 5, the crew reached a distance of 252,756 miles from Earth. This milestone surpassed the previous record, set by the crew of Apollo 13 in April 1970, a distance originally achieved entirely by accident during a life-or-death crisis trajectory. Operating at this distance alters the basic mechanics of human interaction. Radio signals traveling at the speed of light take about 1.4 seconds to reach the capsule, and another 1.4 seconds to return. In normal conversation, a 3-second round-trip gap is a minor annoyance, but during a system failure or a medical emergency, mission control in Houston is functionally removed from the equation. At the edge of the frontier, the crew cannot wait for advice from the ground. For the first time in half a century, 4 human beings were navigating an environment where immediate rescue from Earth was physically impossible, and they were doing it in a spacecraft hiding a highly controversial engineering flaw. In 2022, when the unmanned Artemis I mission returned to Earth, engineers discovered severe damage to Orion's AVCOAT heat shield. Instead of burning away smoothly as designed, superheated gas became trapped inside the material, causing micro-explosions that blew large chunks of the shield off entirely. This diagram illustrates NASA's solution to avoid a multi-billion-dollar redesign. Instead of replacing the physical shield, engineers changed the math. They calculated a completely new approach angle called a skip reentry, where the capsule steeply dips into the upper atmosphere. By bleeding off speed in that first dip, and then temporarily bouncing back out into the vacuum of space to cool down, they calculated they could reduce the thermal stress just enough for the compromised shield to survive the final plunge. On Flight Day 6, the capsule slipped behind the lunar far side. The moon's sheer mass blocked every radio frequency from Earth's deep space network. For 40 minutes, Houston had 0 telemetry and 0 voice contact. The crew floated in absolute silence, shielded from the rest of the human race by over 2,000 miles of solid rock. They were completely alone, knowing their safe return hinged entirely on whether 1,000 computer simulations about a cracked heat shield were correct. On April 10th, Orion slammed into the atmosphere at 24,000 miles per hour. Friction generated temperatures exceeding 5,000 degrees Fahrenheit, creating a cloud of superheated plasma that severed all radio contact for 6 agonizing minutes. Inside Mission Control, engineers stared at silent screens. There was no way to know if the skip re-entry trajectory was working or if the heat shield was failing exactly as it had during the unmanned test. At exactly 8:07 p.m. Eastern Time, telemetry snapped back online. Orion splashed down safely off the coast of San Diego. NASA's highly contested gamble paid off. The crew came home alive, proving that human judgment and rigorous mathematical modeling could successfully navigate a critical hardware vulnerability under the most extreme real-world conditions. From a transactional perspective, spending $2 billion to fly 4 people in a circle is a high price. However, this mission functioned as the mandatory trial run for everything that comes next. This image represents the true destination. The radiation exposure data, the stress testing of closed-loop life support systems, and the validation of that deep space re-entry trajectory are all baseline requirements for a survivable mission to Mars. Yet the mission delivered a second, profound outcome. When the crew emerged from the communications blackout on the lunar far side, they witnessed the Earth rising over a barren, ancient horizon. A $2 billion investment and the calculated risks taken by 4 people provided the technical bridge to Mars. But they also reclaimed a vital perspective, seeing Earth from the vicinity of the Moon as a single, borderless, and heartbreakingly fragile home.